Okay, so if you have been assigned the seasons, you're going to be working in a group to answer these questions. As you guys answer the questions, things will pop up on your screen. So, first of all, you have to follow the directions. It says go to the view menu and then zoom and then change it to 50%. It's easiest if you just go to this drop down menu and then choose 50%. This allows you to see the sun, earth, and moon model that you're going to be creating as you answer each of these questions. So, the next thing says click here to go to the website. So you can just hover over it and then click this. It'll take you to the season simulator, and then you want to pause the simulation in the upper left. So there's a pause button right here. You want to click that pause button. And then it says find light intensity and use location C, Tropic of Cancer, to answer each question. C is in the northern hemisphere. So we're going to find light intensity and we're going to use location C to answer all of the questions. This is the Tropic of Cancer. So if you look on this globe here, it's going to show you 3 locations. A is the Arctic Circle, C is Tropic of Cancer, and E is the equator. So it shows you where each of these locations are on the globe. So the equator is the imaginary line that splits the Earth into the northern hemisphere and the southern hemisphere. This here is a bird's eye view of the sun and then the Earth. AU just stands for astronomic units. It is the average distance that the Earth is away from the sun. Sometimes we're closer to the sun and sometimes we're farther away. But on average, we are 1 astronomic unit away. So they define astronomic units by the distance that the Earth is from the sun. So you're going to be moving this Earth around to different locations. The Earth does move counterclockwise around the sun. Most things in space go counterclockwise. So we've given you a number of dates that you need to use in order to answer the questions. So the dates are right up here. And as you move this, you'll notice that you'll notice that the upper right-hand corner shows you the angles of light that each location is receiving. So the sun is just like our flashlight. It shines the same exact amount of light no matter where the location is. So it's just like the flashlight. It doesn't matter if you're pointing it at your friend's face. It doesn't matter if you're pointing it at your own face. It's going to shine the same amount of light no matter what, unless that battery goes out. So the sun is the same way. It has no idea what location you are at on Earth. It's just going to give you the same amount of light as it gives everybody else. It does not discriminate. So the only thing that does make a difference, however, is because the Earth is round, that's going to mean that the angle of light that each location receives is going to be different. Because the Earth is round, it's going to hit it at different angles. So in this image, the equator is right here. So it hits the equator almost dead on. So it's almost 90 degrees at this date. What that means is that the light intensity is really high. So the higher the bar in these graphs, the more intense the light is. So because it's a 90-degree angle, that's pretty much this is direct sunlight. So as a result, it means that the intensity of light is going to be really strong. So this is going to heat up the Earth very quickly. There is more light concentrated in a smaller area. For the Arctic Circle, on the other hand, the angle of light is really, really low. This means that the light intensity is also very low because the light is spread out over a larger area, just like your lab. When we got to the 22.5 degree angle, or 22.5 degree angle, the area of light that got lit up was huge. So that same amount of light is now spread out over a larger area. Just like that tablespoon of peanut butter is spread out over a larger piece of bread, that means that there's less peanut butter flavor. It is less intense. So same thing with the light. It's spread out over a larger area because of this lower angle, and therefore the light intensity is a lot lower, and it's going to heat up the Earth a lot slower. So this is why we did the lab, is to help you guys understand what light angles have to do with light intensity. So you're going to be moving your Earth to various locations around the sun, and you're going to be looking at the angle of light for the Tropic of Cancer and the light intensity for the Tropic of Cancer, and you're going to need to figure out what season it is. All of those questions you're going to be answering here. So what's the angle of light that the sun hits at the Tropic of Cancer? Answer it here in numbers, and then if you get it correct, something should pop up on the screen. And then is it direct, which means 90-degree angle, very strong, or indirect, which means weaker amount of light? What season is it in the northern hemisphere?